Hello everyone, I'm Aaradhna Soni, Assistant Professor of Sage University, Bhopal. So, in the course of data communication, I'm going to explain the multiplexing. So, let's move on. So, in the previous lecture, we already discussed about the one techniques, that is the FDM, frequency division multiplexing. And in this lecture, I discuss about the WDM, wavelength division multiplexing, and time division multiplexing. So let's move on. And the wavelength division multiplexing is the basically work on the light. We can say wavelength division multiplexing is analog technique in which many data stream of different wavelengths are transmitted in the light spectrum. If the wavelength increase, the frequency of signal decrease. So if we talk about the example of WDM is an optical fiber communication. Use the WDM techniques to merge different wavelength into a signal light for the communication. And the some more topics of WDM. In the fiber communication, WDM is a one type of technology. This is the most useful concept in high capacity communication system. And the end of the transmitter section, the multiplexer is used to combine the signal as well as the end of the receiver section, and the demultiplexer for dividing the signal separately. And the main function of WDM at the multiplexer is the for uniting various light source into the light sources. And the light can be changed into a numerous light source and the demultiplexer. So this is the WDM, and WDM is the commonly applied is to optical carrier. And if you talk about the uses of the WDM, so WDM is commonly applied for optical carrier, and the multiplexing the multiplexing is typically applies to a radio carriers, which is more often described by frequency. And this is purely conventional because wavelength and frequency communicated the same information. So this is the WDM. And if you talk about the block diagram of WDM, so WDM is the wave division multiplexing, and the many inputs and one outputs, and one inputs many output. Convert signal to the optical channel, and after that combine on the all combined fibers, split optical channels and convert optical channel to signal. So this the process is follows in WDM. And after that, the second process is TDM, is belong to the digital signals. And TDM is a time frame is divided into slot. The technique is used to transmit a signal over single communication channel with allotting one slot for each message of all the types of TDM. The main ones are synchronous and the asynchronous TDM. So basically the TDM is work on the time, and if you have the many inputs, so one inputs are the defined, and they are the used to the slots, and each slots is allowed to a message. So this is the time division multiplexing. And time division multiplexing again divided into two parts, synchronous and asynchronous. And some more points of TDM. TDM is a one kind of method for transmitting a signal over a channel of a particular communication by separating a time edge into slots. Like single slot is used for each message signal. So this is the input lines. Red line is so the time one and the time two, and after the merging of both the time, the signals are like that, digital 0101 like that. So this is the time division multiplexing. And the time multiplexing division into categorized in two parts, synchronous and asynchronous. So this is the example of synchronous TDM. Synchronous TDM is known as the defined time. So each slot is defined into the time and allowed to one slot is allotted for each input lines. And they talk about the techniques and the sapling rate of the common for all signals, and hence the same clock into is given, and the mux is that is known as the multiplexer is allowed the same slot for each device at the all times. Synchronous, it means thus all inputs in divide into same times, that is known as synchronous stadium. And all inputs is not defined and not defined by the times, and clock pulse is not used here in this if you talk about the asynchronous. So this is the asynchronous TDM. uh, and the some advantages of the multiplexer. So multiplexer is basically is one work on the signals, that is the one signal can be transmitted over a single medium, and the utilization of a medium bandwidth can be done very effectively, and enhance the economic stability and reduce both the time as well as cost. And in used in telecommunication, multiplexing play a key role to reduce the cost of network, and this is the advantage. And if you talk about the application, so application is analog broadcasting, digital broadcasting, telephony, video processing, and telegraphy. And this application is very useful in multiplexer. And what is the telephony? Telephony, uh, uh, those devices where we not use the wired signal, and telegraphy we use the wired signal. So that is the difference between the telephony and telegraphy. So this the many use of multiplexer, and I hope you like my lecture. Thank for watching.